The first way that may eliminate subtours is the following. So for the problem about subtour is that given a network like this, okay, one possible subtour is this one and that one, right? So that means in this small subset, you are having too many arcs. You are having too many arcs. So the first idea is to exclude this possibility. For each subset of nodes with at least two nodes, we limit the maximum number of arcs that can be selected. Okay, so let S be a subset of nodes. Okay, subset of nodes, and this notation means it's really a subset. It's a proper subset. So S is not the whole set. Okay, and we also need S to be at least containing at least two nodes. For those kind of subsets, the number of arcs that may be selected in that subset is limited to be at most S cardinality minus 1. Okay, so for example here, if we are talking about, let's say, these two nodes, okay, these two nodes form one subset, then the number of arcs that you may select in this subset can be at most 1. So this would be infeasible. Okay, this would violate this constraint. So that means your formulation can eliminate a subtour like this. On the other hand, what if we have another network like this? Again, I'm drawing an undirected network, but please imagine that it is directed. Then, if we are talking about a subset like this, and we say we need to choose at most two arcs, then it's impossible for you to select, for example, 3 arcs like this. Okay? So given any 3 nodes, you cannot select 3 arcs. So you cannot have a cycle with 3 arcs. If that's true for 2 nodes, 3 nodes, 4 nodes, 5 nodes, blah blah, up to n-1 nodes, then the only allowed cycle is the cycle that containing n arcs to pass that n nodes, and that's exactly what you need. Okay. Of course, this problem, this way has some disadvantage. Is that when you have n nodes, you're going to have 2 to the power of n minus 1 constraints. Okay, the number of constraints is exponentially large compared to the number of nodes. So your program would be very, very long. So that's obviously one disadvantage. Another alternative is the following. It's more complicated, but the number of nodes and the number of constraints would be smaller. Let's use UI to represent the order of passing nodes in your tour, or more precisely, UI would be k if node I is the kth node to be visited in a tour. Okay, so UI is 1, means this is the first node. U5 is 2, means the second I want to visit node 5, and so on. Then let's add the following constraints to make this happen. First, U1 is 1. I am assuming that the first node is our starting point. Okay, so UI is 1. For all other nodes, UI would be between 2 and n. Okay, not very surprising because I have n nodes. And then is the last constraint. For each arc, without node 1 as one of its endpoints, okay, we want to have the following constraints. So let me slow down for a while. Suppose I have a network like this, okay, and I say this is node 1. So u1 is 1. Okay, then this constraint is saying that for every link that is not related to node 1. Okay, so I am not talking about these two arcs. I only talk about the remaining arcs. So for each of the remaining arcs, I have this. What's this? Looks very similar, right? It's again an either or constraint. Suppose xij is 0. That means suppose I do not select that particular arc. Then this part would be 1, this would be very large, and this constraint is redundant. If xij is 1, however, that means if I select that arc, then I require ui to be at least 1 unit larger than uj. Uj is required to be larger than ui by at least 1. Okay, you put uj to the right hand side. So why do we need that? We need that because we want, once we select one arc like here, okay, then uj should be larger than ui by at least 1 unit. Why do I say at least? Because if you think about the whole network, let's say something like this, then what's going to happen is that u1 is 1, and then here u2 is 2, u whatever is 2, let's say u2, and then say this is u3, u4, and u5. Here u5 it would be 3, this would be 4, and then this would be 5. Okay, so you can see this constraint really can make this happen. You make those UI denoting the order of visiting different nodes. What's more important should be what's going to happen if we have a subtour. Okay, so let's assume that we have a subtour like this. It's two parts. Now let's say here. Let's say we have a subtour from node 2 to 3. 3 to 4, and then 4 to 2 again. In that case, if you look at this constraint, okay, that means u3 must be greater than u2 by at least 1. u4 must be greater than u3 by at least 1. And then u2 must be greater than u4 by at least 1. Okay, if all those things must be satisfied at the same time, the constraints here would push all those related UIs to infinity. But again, that's impossible because you have upper bounds for your UIs. Okay? So if you have a cycle, a subtour here, then that's going to violate these constraints. How about the largest cycle? The feasible tour is not going to having this trouble because node 1 is not restricted with these constraints. Okay, so the only cycle, the only tour that is feasible is the largest tour, which is you want. Now, if you have n nodes, you need to add n variables, UIs, and this amount of constraints. It's just n to the power of 2 scale. Okay, so the number of constraints is much smaller. So now we are able to write down the complete formulation for TSP. You want to minimize the total distance, subject to incoming and outgoing and the binary constraints. Then you also add either alternative 1 or alternative 2 into your formulation. You don't need both, you just need one of them. Then very naturally you would ask the following question. Should I add alternative 1 or should I add alternative 2? Which one is better? Okay, which one is better? If we talk about the number of constraints, of course alternative 2 is better. But if we talk about the efficiency of solving the problem, then you know fewer constraints does not mean faster. Okay, so you probably want to know whether alternative 1 is better or alternative 2 is better in terms of the computation time. There is an answer, but I don't want to tell you right away. Maybe you want to look online, check textbooks, check other books to see if you can get anything. Okay, and then if you are interested, let's discuss. Anyway, at least you know there are two alternatives, either this or that. Please understand why they work, because when you start to formulate your own problem, you may need them. Okay, that's today's lecture. Thank you.